This is MATHguide.com. My name is Mark Karadimos, and in this video we're going to talk about the binomial theorem, and we're going to specifically expand binomials. In this video we are going to have 4 sections. Section 1 is an introduction to binomial expansion. Section 2 is Pascal's Triangle. Section 3 is a problem. We'll call it expansion number 1. And section 4 will be another problem we'll call expansion number 2. Okay, let's get started. Alright, this is section 1. Okay, let's talk about what it means to expand a binomial. Now, I guess there's a couple concepts or terms that need to be discussed first, like what is a binomial? Well, here's examples of some binomials, like let's say 5x minus 2 or 3x plus 1. These are all perfectly good binomials because they have 2 terms. Here's the first term, second term. Here's the first term, second term of our other binomial. Okay, what does it mean to expand binomials? Well, we're going to be taking binomials and we're going to be raising them to certain powers. Like, for instance, we could take x minus 3 and we can square it. Now, a long time ago when we squared this, we just really took x minus 3 times x minus 3 because that's really what squaring means. It means you have 2 factors. Okay, so we multiply these using a table. So I placed a table here up on the screen so I could facilitate the multiplication here. So I'm going to take x times x. I've got x squared. I've got x times negative 3. I got negative 3 times x. And a negative 3 times negative 3. Okay. So I get these 4 terms which I then add together. You'll notice that we could combine like terms here in the middle. And there you go, there's the answer. Now of course when we do expansion of binomials there are shortcuts, but this is how we did expand this binomial to get the answer that we're looking for. But in this video you'll see shortcuts, which takes us to our next section. This is section 2. Alright, let's talk about Pascal's Triangle. So you can see over here that I do have a triangle. Well, it's a triangle made of numbers. And you can see that on the left of the triangle I have a series of 1s. And here on the right side of the triangle I have a series of 1s again. And I've got these other numbers in the table. So let me explain how it is you're supposed to get these numbers. Okay, so according to the pattern, you're going to take 2 numbers that are adjacent to each other, you're going to add them, and you put that sum between the 2 numbers, but lower. Okay, so in other words, I'm going to add these 2 guys together, and I get 2. Okay, so if I add 1 plus nothing, there's really like a nothing over here, or really if you think of just the ends always being 1s, that's actually easy to think. So since the 1 and the 2 are already here, let's add those 2 numbers. You get 3. Okay, likewise if I want to keep going down the table, like for instance, how do I get 10 here? Well, I add 6 and 4. When I add 6 and 4, I get 10. So if I were to continue this table again, or triangle I should say, if I were to want more rows in this triangle, I would just put a 1 on the end, I would put another 1 on the other end, and I would add these 2 numbers and get 6. I'd add these 2 numbers, you get 15. Add these 2 numbers, you get 20. Add these 2 numbers, you get 15. Add these 2 numbers, you get 6. Another little feature that you should notice is that not only, I mean, that's how you're supposed to get rows in this pattern of triangular pattern of numbers, but there is symmetry in the table of values here. You can see that you have 1, 6, 15, 20, and then it goes down 15, 6, 1 again. So numbers on the right side appear on number as they are on the left side, except they're mirror images of each other. Okay, let's do one more row. So 1, well actually 1's on the outside. Add 1 and 6. Add 6 and 15. Add 15 and 20. 15 and 20. Okay, I'm starting to repeat. Oops. I'm starting to repeat now. So I'm just now going downhill again. Add those, I get 20. Add those, I get 7. 21 that was, I get 7. Okay, and I can continue this pattern indefinitely. How is this used? You'll see this in the next section of this video. This is section 3. So in this section, what we're going to do is take an example and take a look at how it is you're supposed to expand a binomial. So when you do expand, like for instance, let's say I was going to take a binomial like a plus b, which I like to use a and b for my generic polynomial, my generic binomial that is, and let's say I wanted to take it to the 5th power. Now I could keep on multiplying a plus b times a plus b times a plus b 5 times. I'm going to be here all day. There's a shortcut, and then I want to explain what that pattern is to that shortcut. Okay, well, the highest power I'm going to get for a is going to be a to the 5th. Right? If I multiply 5 a's together, I'm going to get a to the 5th. So there will also be a to the 4th. There's going to be a cubed. There's going to be an a squared. There's going to be an a. And then there's going to be no a's in the last term. Okay, now what's going to happen with the b's? There's going to be no b's in the first term. There's going to be 1 b in the second term. 2 b's in the third term, b cubed in the 4th term, b to the 4th in the 5th term, and we've got b to the 5th in the last term all by himself. So those are what the letters look like of the terms, and there's 1, 2, 3, 4, 5, 6 terms to this expansion. Now you'll notice that I'm leaving blanks in front, coefficients. The way you get these values from the for these coefficients is you use Pascal's triangle, and you find the row of Pascal's triangle that matches the number that I need, and I need 1, 2, 3, 4, 5, 6 numbers. So you go to the row of Pascal's triangle that has 6 numbers, and I did earlier, in the row that has 6 numbers have these values. Okay, so I'm putting plus signs in between, trying to be as neat as I possibly can. Okay, so now we could actually see the terms a little bit better. Okay, so I have this set up. You kind of see that there's the symmetry of the numbers from Pascal's triangle. You can see that there's an interesting pattern with powers. So here we've got a 4. Here's first power for b, which normally you don't write, but you notice that adds up. 4 and 1 adds up to be 5. Here you can see 3 and 2 adds up to be 5. Here you can see 2 and 3 adds up to 5. Here you can see 4 and 1, normally we don't write the 1, that adds up to be 5. All the terms have a sum of exponents that add up to be 5. It's a nice little pattern. It helps you write down all these. Now I expanded this because the first problem we're going to take a look at is really going to be 2x minus 1 to the 5th. So if this is a problem you'd be asked to expand, what you would do, and this is what I suggest that students do, is you write down what the generic polynomial looks like. A plus b to the 5th, which I already did. And so to solve this problem, I'm now going to substitute. Wherever I see an a, I'm going to put in a 2x. Wherever I see a b, I'm going to put in a negative 1. Okay, so how does this look? Well, I keep the coefficients right where they're at. I replace a with 2x. Okay, I'm going to replace a with 2x. I'm going to replace b with negative 1. Okay, now of course I'm going to need some room here, so I'm going to try to squeeze this in. I hope it all squeezes in here. So a, again, we said was 2x. I got to write a little smaller. B is going to be negative 1. Okay, so I'm replacing the a with 2x, the b with negative 1, yeah, looks like I don't have enough room here for this last term. I'll put it down here. So I'll put b is negative 1 to to the 5th power. Okay, so that's what it looks like when I expand that polynomial. Now what I have to do, of course, is clean up this mess. And it is quite a mess. Okay, so how do I clean this up? Well, I'm going to take 2x to the 5th. So that means 2x times 2x times 2x times 2x times 2x. In other words, I get 2 raised to the 5th power and x raised to the 5th power. There you go. There's my first term. Okay, how do I get the next term? I'm going to get negative 1 times all this, so I know I'm going to get a negative answer. I got 2 to the 4th, that's 16. And 16 times 5, which I did earlier, 16 times 5 is 80. And I'm going to have x to the 4th power. Okay, let's now work with this term. I'm going to have, I forgot to put the square here, didn't I? Yes, I did. Okay, so when I take negative 1 and I square it, that's going to get a positive value, positive 1. So I know it's going to be positive for this term. I'm going to take 2 and cube it. 2 cubed is 8. 8 times 10 is 80. And again, I'm going to cube the x. Okay, if you haven't already noticed, it's going to alternate positive, negative, positive, negative. See, because I have a negative number to the 3rd power, that's negative 1. 2 squared is 4. 4 times 10 is 40. And I'm going to take x and square it. Okay, let's do the next term. So the next term, I'm going to have negative 1 to the 4th. That's a positive value. And I'm going to just have 2 times 5. And that's going to be the x there. Okay, and the last term, I have negative 1 to the 5th. That's just plain old negative 1. And there you go. I just expanded this polynomial. This binomial I expanded to the 5th power, and there's the result. Alright, let's try this again with another example. This is section 4. We're going to take a look at another problem and do it to completion here. Let's take a look at another problem. So we're about to do a problem that's going to be to the 6th power. So I'm going to take this generic binomial and I'm going to raise it to the 6th power. Okay, so what does it look like? Well, if you remember, I'm going to have the highest power being a to the 6th. Then it's going to go a to the 5th, a to the 4th. You can see I'm just going down. I'm counting down here for each term. And then there's going to be an a, and then no a's. Okay, on the opposite end, b is going to be going up in power. So there's going to be no b's in the first term. B to the first, b to the second, b cubed, b to the 4th. It's hard to see that, 3. Okay, and then there's going to be a b to the 5th, and then a term all by itself, a b to the 6th. If you do this right, all the powers in each term should add up to be 6. So here it adds up to be 6, 6, 6, 6. There's a 1 here, remember, so that's 6, and a 6 right there. Alright, so everything's turning out well. Now, if you remember, I also have to place a coefficient that goes in front. We should do this in a different color. So I'm going to have to put a coefficient in front of each one of these terms. So what you're going to do is you're going to go to Pascal's Triangle. This is one way to do it anyway. Is you grab the numbers of the correct row that has this many numbers. 1, 2, 3, 4, 5, 6, 7, which is always going to be one more than your power. So the row of Pascal's Triangle that has 7 numbers are these: 1, 6, 15, 20, 15, 6, and 1. Those are the values we're going to use. Got them from Pascal's Triangle. Now the problem I want to do is, well, I kind of did this problem in section 1. I talked about x minus 3 squared. Well, let's see what it looks like if we take x minus 3 and raise it to the 6th power. Well, again, I'm just going to make this connection where the a gets replaced with x, and I'm going to replace the b with negative 3. Okay, so you go through this problem, and you go, okay, a to the 6th, a is x, the 5th, We're going to replace the b again with negative 3. Trying to write small. I don't think I'm going to be able to squeeze this on one line here, but I have 15 x to the 4th. b is negative 3. Okay, next term, 20 x cubed. b is negative 3. Then I've got a 15 x squared, negative 3, and that's the 4th power. Okay, continuing on, I got to go down here for this coefficient starting with the 6. That's going to be a. Oops, sorry, a was x. Easy to make a mistake here. And replacing the b with negative 3. Okay, last term, I put a 1, and b is negative 3 to the 6th power. Alright, so then the job becomes cleaning up this mess. Alright, so let's take it term by term. So our first term, which we should write this down. The first term right here, well, that's easy. It's just x to the 6th. Pretty simple. Okay, now it's going to get a little bit harder, and the numbers are going to start to get big. Okay, well, here I'm going to take negative 3, x to the 5th, times 6. So that should just be negative 18. That's not a big deal. Okay, let's multiply the next term. Okay, so the next term is going to be, let's see, negative 3 squared, that's 9. 9 times 15 is 135. I did the multiplication earlier. So 9 times 15 is 135, and I've got x to the 4th. Okay, next term. I could see the next term is going to be negative, and again, you could see it alternates. Positive, negative, and it's going to keep continuing with that pattern. Let's see. Okay, so we said this is x to the 4th. Sorry, we're on the x to the cube term. So for the x to the cube term, we're going to take negative 27 times 20, because that's what negative 3 cubed is. So negative 27 times 20 is negative 540. And we're getting x cubed. Alright, on to the next term. We're going to take, this is 81 times 15. 1215 x squared. Okay, on to this term. We're going to take negative 3 to the 5th power. That's 81 times negative 3. I don't know what that is, but it's negative 81, I'm sorry, positive 81 times negative 3 times 6. In other words, negative 3 to the 5th power times 6, which is 1458. Negative. Okay, and that'll be x. And our last term is just negative 3, quantity negative 3 to the 6th, which is going to be a positive value, 729. And there you have it. You'll notice that I have all these powers going down in value, and I'm alternating positive, negative throughout the way. If you didn't have any negatives here, it would all be positive terms. Alright, that's it for this video. Make sure you go back to MATHguide.com, check out our other videos, our interactive quizzes, and of course our text-based lessons. Take care.